You should have out page 11 of your 1F packet to go along with this video. We're working on percents, and I'm starting with the problem of the day page. Write an algebraic equation that can be used to get the answer in one step. Okay, again, one step, only this time we're writing an equation. And equations do need an equal sign. So it needs an equal sign or an equal symbol. So an equation, a full thought, a full mathematical thought, like a sentence in English is a full thought. So writing an equation that can be used to get the answer in one step. Find the discount D or the sales tax S. So just finding discount and sales tax. So the cost of an item is C. The discount is 30% off. So the discount D, we're changing our percent to a decimal and then multiplying, we would get D equals 3/10 C, or 3/10. I know some of you like to show it as 30/100ths times the cost of whatever the item is, C. So I'm using two variables here. It's like Y equals K, my rate of percent, 30%, X, using two different letters. The cost of the item, $60, $50, $90, $80. If the discount is 30%, change the percent to a decimal and multiply by the cost to get the discount. So D equals 3/10 C. Sales tax. To find the tax on an item, the cost of a TV is C. I don't know, $400, $500, $600, $399. The sales tax is 8%. To find just the tax, not the total, just the tax, change your percent to a decimal, so move it back to, you get 8/100ths, times the cost of that TV would give you the sale price. So S is the sales tax. So S equals 8/100ths times the C. You can see it written here. Or you could write it as the fraction 8/100ths C. So to find tax, change the percent to a decimal, multiply it by the cost, and you will get the sales tax S. S equals 8/100ths C. So the original price of a CD, let's call it C. I don't know. The CD could be $12.99, $8.99, $3.99, $4.99, $5. The original price of the CD, we're just going to call it C. To find the discount, write an equation. So D equals the discount. D is the discount. I would change the percent to a decimal, 5/100ths, and multiply it by the cost of the CD. D equals 5/100ths C. I could say Y for the discount equals 5/100ths X and put it in Y equals KX form, or use D for discount equals 500 times C, the cost of the CD. The cost of an oil change. The cost, C. The markup is 70%. So what is the markup total price then if it's marked up 70%? So the markup could be M equals, changing the percent to a decimal, 7/10 or 70/100ths times the cost. M equals 70/100ths C, or the markup, what is it? 7/10 times the cost of the oil change, marking it up 70%. So we're writing equations. Notice that each one of these has an equal sign. Key idea here. Find the total cost of the item. Find the T, the total cost. So now we're going to be doing method 2, where we're going to add or subtract, because we have to do it in one step. Remember, one step to get that total cost. So we're going to have to use method 2, where we add or subtract from the 100%. I'm not finding, like up above here, just the discount or just the sales tax for just the markup. How much was that discount? What am I going to say? How much is that tax? For instance, $4.32. What is that markup on the item that you're purchasing? If you're just finding those things, that's a different question than finding, oh, what's it totally going to cost to you? So the total cost to you, the consumer who's buying that item. So if the cost of an item is C, and again, we're writing an equation, not an expression. How do I figure this out? The cost of some item is called C. The discount is 30% off. So I know 100 minus that 30% would equal 70%. So I'm going to use method 2. I'm going to subtract. So to find something 30% off, I could say, oh, to find the total, what is it going to cost to me? T equals 70% is what it's going to cost me. So 7/10 times whatever that item costs. T equals 7/10 of the cost of the item, C. I know some of you like to put that 0 on there, 70 hundredths. See, it's the same thing. You really don't need that 0 though. 7/10 is good enough. Or you could use the equivalent fraction as you see here. T equals 7/10 C. Key idea here, equal sign. We're writing an equation in one step. How could I get what does it totally cost me? So the cost of a TV, C, say it's $400, and the sales tax is 8%. I know in the real world, I have to add my tax on. So sales tax is added to the 100% that you're going to pay for that TV already, and you get 108%. Moving the decimal back to, you would multiply the cost of the television, say it's $400, times 1/800 to give you the total T cost. So T equals 1/800 times whatever the television costs, 400, 500, 300, 299, whatever that television costs. Multiply it by 1/800 and you will get the total. So the cost of a CD, again, let's call it C this time, and the markup is 30%. Markups are added. So the markup would be 100 plus that 30%, which would give me 130% is the percent I would use in the problem. Change the percent to a decimal, and I would get the cost of that CD is 1 3/10 times the cost of that CD equals my total, what it's going to totally cost me. 1 3/10 times the cost of whatever that CD is. $11.99 times 1 3/10, that's what it's going to cost me. Number 9 here. The original price of a concert ticket. Okay, the original price of a concert ticket. Let's use P for price. It's discounted 21%. Well, if it's discounted 21%, I know I'm going to pay 79%. The discount's 21%, I'm going to pay 79%. So changing that percent to a decimal to find that the ticket will cost 79 hundredths P. The total price of the ticket to me is going to be 79 hundredths. If it's on sale for 21% off, I'm going to pay 79%. Use that percent, multiply it by the price of the ticket, that will give you your total. The cost of a puppy. So you go to a local pet store and the puppies, they're increasing the price of the puppy by 41%. Well, markups, 100 plus 41 would give me the puppy equaling 141%. But then they decide after a couple days he hasn't sold, oh, poor thing, then they decide to discount it 23%. So the discount, 100 minus that 23%, would give me 77%. So I could take the to find what the cost of the puppy is, let's say C, we'll say C for cost, it would be, the total would be, okay, first mark it up, 41%. So that would be 1 41/100ths. And then give a discount of 23%. That would be 77% of what he originally C cost. So you're doing two things here. First, you're figuring a markup, adding the 41% on. Then you're figuring a discount, subtracting the 23%. And the cost of the puppy would be total equals 1 41/100ths times 77/100ths times C. So say the original cost of the puppy was $100. $100 times 1 41/100ths times 77/100ths would give you what it would cost you then to buy that puppy. Let's go to the next page. Apply some of this. Some real world percent problems. Leon deposited $30,000 in a bank which paid 2% interest per year. Yes, banks aren't going to give you a lot of interest. Maybe on $30,000 you could get a little higher interest rate, but probably not much better than that. After 1 year, Leon withdrew all his money, including the interest that he had received. How much money did Leon withdraw in all? So if you're if the bank's paying you interest, you're earning interest. Your money is growing by 2%. So I could use that 2% and add it to the 100% that I know Leon's going to get all 100% of his $30,000 back, plus another 2% of interest. So his money grew by 102%. I'm going to use that fact. So if I take my percent and change it to a decimal, how much money did Leon withdraw in all? His total would equal 1 200ths, 102%, changed to a decimal, times his original investment of $30,000. So he must be a businessman or something. So altogether, if I multiply that, I get that he's going to have $36,000 coming back to him. So Leon would withdraw $36,000. Because it's a real world problem, we are going to sable it. Leon would withdraw $36,000. Now, the question did not ask, what interest did Leon earn? I could have done this problem a little bit differently. If it asked, what interest would Leon earn in 1 year, then I would only use the 2%. So if it asked, what was the interest, if that was the question, you would use just the 2%. Da-dun-da-dun. And you would multiply 200ths times that 30,000, which you can see that his money went up by 6,000. That would equal $6,000. That's just the interest. If the question asked, what is the interest, I would just use the 2%. But it didn't ask that. It says how much money, including the interest, is he going to withdraw. So I used method 2 and did 102%. In a flower shop, 4 flowers cost $10. Mrs. Watson usually buys 12 flowers. During a sale, there is a 20% discount on every flower. How many flowers can Mrs. Watson buy during the sale if she spends the same amount of money that she usually does? Ooh, lots of steps here. At a flower shop, 4 flowers cost $10. So let's figure her cost per flower. Remember, Y is always cost. So my cost, which is Y, divided by my X, which is flowers. So I'm finding a unit rate. What is the cost per flower that she normally pays? So it's $10 for 4 flowers, 10 divided by 4. My cost per flower would be $2.50 per flower. So I found a unit rate here. Each flower costs her normally $2.50. Normally she buys 12 flowers. Okay, so 12 times $2.50 per flower. Normally she spends $30. 12 times $2.50. So that's what she usually spends, $30. Okay. During a sale, there is a 20% discount on every flower. So they're saving 20% off every flower. How many flowers can Mrs. Watson buy during the sale if she spends that normal $30 like she normally would? She's going to be able to get more flowers because they are 20% off. That would make sense. She usually gets 12 flowers. I bet she'll be able to buy more than 12 flowers because they're not going to be $2.50 each. In fact, they're 20% discounted. I'm going to do method 2. If it's 20% discount, 100 minus that 20%, she's paying 80% for each flower. So I'm going to figure what's 80%. 80%, dun-dun-dun-dun, would be 8/10 times that normal price of $2.50. What's 80% of what she normally pays? Well, that comes out to be $2 exactly. She has $30 to spend. What can Mrs. Watson buy during the sale if she spends, how many flowers can she buy if she spends the same amount of money that she usually does? She usually buys 12 flowers at $2.50 each, costing her $30. Now she can buy flowers at $2 each and she still wants to spend $30. So our last step here would be to take our $30 that she wants to spend and divide it by $2. Well, now she can buy 15 flowers. Lots of steps on this problem. You had to read it very carefully. So Mrs. Watson can buy 15 flowers because they're on sale. Mrs. Watson can buy 15 flowers because they're on sale at 20% off. So because she's saving money, she can buy more flowers. That makes sense. Normally she buys 12. Now she can buy 15. A jacket with a regular price of $79.99 is on sale for 35% off. Estimate the sale price. Oh, estimate the sale price of the jacket. It's 35% off. Well, that means you're going to pay 65%. So estimating, I could say, oh, I'm going to change that 100 minus 35 is 65%. I'm going to round that up to 70%, which would be 7/10 or 70 hundredths. And I'm going to round up, because it says estimate, I'm going to estimate $79 to be $80, $79.99, pretty darn close to 80. So that would get me that the price of this 7/10, 7 times 8 would be around $56. That's not one of my choices, but it's very close to number A. What's another way I could estimate this? Well, I know 10% off of 80. 10% of 80, I've taught you all this, is just take the 80, then and move it back one. So 10% off would be $8. Well, 8 times 4 would be $32 off. So 100, if I round that to 40%, if she says 40% off, 80, not $100, $80 minus 8 times 4 is 32. That would get me, approximately $48. It's halfway between there, 48 and 56, which is right around $52 would be halfway between those. I think 53 is the closest that we're going to get there, $53. 80 minus 32 would be 48. If I say I went to 80 minus, 10% is 8. 8 times 3, say I go 30 that's $24 in savings. Well, half of 8, that's easy to figure out. I could actually do 35% because half of 8 is another $4. So if I save $28 on an $80 item, that gets me to 52, which that's halfway between this 56 and 48 because one time I did 40%, another time I did 30%. Here's actual 35%. Lots of ways to do this, as you can see. And yes, A is the closest answer, $53. Oh, it's about $53 for that jacket. Next page. I'm going to do number 1 and 3 and 4, and you are going to do number 2, 5, and 6 on your own and come to class tomorrow with these 3 done. So I'm going to do numbers 1, 3, and 4 on this page. Mr. Ramsey measured a board to be 42 inches. It was actually 40 inches. Oh, I'd be shocked if Mr. Ramsey was that far off. But find his percent of error. Well, 42 take away 40. The actual is always on the bottom. That's the x, the denominator. So my difference is my y. Y divided by x will give me my k, my rate of percent. Well, 2/40ths is the same thing as 1/20ths, which I recognize that as 5%. Or 1 divided by 20 on your calculator would give you 5/100ths. Move it over to 5%. So Mr. Ramsey had a 5% error. I'm not going to sable that, but that would be the sable if I was going to write that down. Mr. Ramsey would have a 5% error. Don't tell him I said that. Number 3, a bottle of Voss water costs $3.50. If you have a coupon for 15% off, how much will you save? 15% off, how much will you save? It doesn't say how much you're going to pay. So 15% off, I'm going to figure 15%. Not how much you're going to pay. I would pay 85%. So I am going to actually use 15%. Move it back to 15% times $3.50 would give me a savings of 52.5 cents. Well, rounding to the nearest hundredth, because money does round, I would save 53 cents. So you would save, how much would you save? You would save 53 cents would be the sable. Mrs. Agulia invested $600 in an account that pays 2% interest. How much money will she save after 5 years? Okay, 2%. I, being math savvy, would probably put it in a little bit higher percent account though, but we'll go with this one. 2% times $600 would give me a savings of $12 every year. That's for 1 year. In 1 year, I would save $12 per year. While I'm doing it for 5 years, how much money would I earn in interest for savings? Well, how much money will she have after 5 years? Well, first of all, I got to do $12 for 1 year times 5 would be $60 in that 5 years. So now my account would have my original $600 plus my $60 of interest, not very much after 5 years, would be $660. Mrs. Agulia would probably find an account that had a better interest rate on it than that. But we'll just leave it like that. How much money will she have after 5 years? She'll have $660. Now, you're going to finish numbers 2 and 5 and 6 on your own, and tomorrow in class, those are the first ones that we'll go over.